Hey everyone, this is Jim Bagwadia, and we are in the community meeting for Kyverno for March 17th. I'll hand off to Shooting, and we'll cover some of the agenda topics for today, and we'll get going.
Thanks, Jim. Hello, everyone. This is Shooting. Welcome to the Kyverno community meeting. So today we're gonna have two demos from the team, and then I'll talk about the main issues that we're currently working on, and we'll discuss about the items on the roadmap. All right. To start off, we'll have the demos from the team. Maybe I'll first switch to Pooja. Pooja, are you ready for the CLI demo?
Yeah, sure.
Stop share.
Hey guys, today we have a demo for namespace selector. In the previous meeting, I showed you how the namespace selector works in the server. Now we will see how we can test it in the CLI. So namespace selector. What is namespace selector? So this is our new filter that we have introduced, and this is something you can filter the resource based on the namespace in which it is created, and filter is basically on the namespace labels. So here I have a simple policy which will be applied on a kind pod, and in the namespace selector I have mentioned the key as managed state and the value is managed. So this is something will be applied on a namespace with label something like this. So this is about the filter and the validation part, what it is going to validate. So validation is the name of the pod should end with dash nginx. So if you want to see the example of a namespace, the namespace will look something like this. With I have just kept two labels just to show an example. So here the main label is this managed state managed, and now coming how you can pass it in from the CLI. So for that you have to use value file, that is also used for passing the variables. So here you're going to mention a field namespace selector. Under this, you can provide a list of namespace details. So this is the first list. The first thing is name, the name of the namespace. So here I'm taking the name as test1. I have kept it here. Under this, we will have a field label. Here you can mention the label of the namespace. So here I have mentioned the labels. Now, first I'll show this. So this I'm going to apply um, this policy on this resource. So this is something you can see the namespace is test1, and the container is here. Name, yeah. So this is the name. So it will fail as it is not ending with dash nginx. So this is something should be there at the end, but we have only nginx at the end. So let me apply and show you. So here how to pass, apply the policy name, minus r the resource name, minus f the variable file name. So you can see it fails. Now the second example will go where it should pass. So this is dash nginx. So it should pass. So here you can see this passes. Now the third example I have, that is where the pod is not under any namespace. So this will also pass. Like when you apply from the in the server side, this will get successfully created as it is not counted under the filter. So here you can see it passes. So this is the example I have. This is a basic example for the namespace selector. So any questions if you have, you can ask.
Pooja, I have one question.
Yeah.
Yeah, so can you go back to the manifest containing the match expressions keyword for the namespace selector?
This one?
So yeah, so here, like, please correct me if I'm wrong. So here we are identifying the bunch of namespaces via the labels which the namespace contains, right? Like in this
Yes.
situation, it was managed state. So is it
Yes.
possible to just give a array of the names of the namespaces to this namespace selector? Like
Array
let's say there
of
are five,
the,
like let's say there are two namespaces. Let's say default namespace, my namespace one, and my namespace two. These are the three namespaces which I want to apply this cluster policy to. So like, is there a way under this namespace selector to identify the namespaces by their names and not their labels actually?
this is actually based on the namespace labels, not based on the names.
Okay. Because I was thinking that right now, let's say if I want to apply the same policy over, let's say, three of my namespaces. So I have only, like if I'm not wrong, then I have only one choice to apply namespace policy, the same policy over those three namespaces. So that would add up to a little redundancy over them. Or I have to add some labels and then use those labels to use this namespace selector. So that's what I had the question regarding, but yeah, cool, it's fine, I guess.
Okay.
Yeah, I think the best practice would be to use labels generally, but if you do want to just match by names, you can also use preconditions and kind of use a set. So you can say if the name is in one of these names. So that would be another way. But for the selector specifically, because we're doing an API call and a lookup, the best practice here is to just use labels to find the list of namespaces that match.
Sure, fair. Thanks.
Okay.
Cool. So this will allow then to now policies with namespace selectors. We can also test in a CI/CD pipeline without having cluster access, right?
Yes.
Cool.
Okay, then I hand it over back to shooting then.
Great. Next, we have a demo from Venkatesh. Hey, Venkatesh.
Yeah. Hello, everyone. Today I'm going to show the demo for extend the match and exclude to use the API version, API group and the API version. So previously we are just in the resource and the exclude, we are just passing the kind. So now we are extended to the group and the group version. So the first example which I have to validate the Knative service. So here's the policy. So in the policy, we will disallow the namespace which matches the resource, the group, the Knative group, and the service with the resource, the API version, and the group. So let me. So now I am creating the resource with the default namespace. So it should get validate because we are passing the API version and the service which matches with the kind which we pass in the policy. So, yeah. So as expected, it's not allowed to create the service in the default namespace as it matches the group. So now I am creating the another service which get not match with the policy kind which we defined here. So I am creating this service with API version v1. So this service get created as it's not match with the kind which we defined in the policy. So the another example which I have with previously I showed with the group the GVK, and the next example which I have with the version and the kind, in which I am validating the latest tag for the resource. So here I am passing the two parameters, the version and the pod, and the resource. I have the pod and the version. So the service get created. Now I am going to create the resource with the latest tag and the API version v1 and the kind. So it should get validated. Yeah. So as we can see, it's get validated. It's match with the kind which we defined here, and it's validated here. So next example which I have about the generate. So in the kind, these policies to generate the network policy. So in the kind, I am passing the crystal role with the GVK. So if it match with the API version and the group, it will create the network policy here. So I am creating policy. The policy got created. Now I am creating the resource with this the crystal role and the API group version. So it should create the network policy at its match with the resource, the GVK. Our policy get created. So yeah, yeah. So that's all I have. So so now we are extending the kind to the GVK, so we can pass the group version and kind to the validate, generate, and the muted resources. Any question?
Okay, so by default, we can still accept only kind
Yeah.
and this list, right?
Yeah, by
So
default we can.
Mhm.
Does
Yeah,
the kind have to exist at the time the policy is created? I can't remember from the PR. Will it fail the policy creation? Does it go and look it up at that time, or can it exist independently of the kind actually existing in the API server?
Oh, you're talking about the CRD?
Yeah.
Like in this case, you have to have the CRD registered first, and then
Okay.
Kyverno is able to look up that object.
So if you don't have it registered and you try and create the policy that references it, it'll just fail.
No, it
So
won't. The application won't apply, but the policy creation will go through.
Okay, so it will let you create the policy. It's just that it's not able to validate anything if there's no CRD.
Right.
Yeah, okay.
And Venkatesh, this works with the CLI too. Now you can test these specific CRDs with group version kind.
yes, Jimmy. So I don't have the demo now, but yeah, it will work.
Okay.
All right. Thanks, Venkatesh.
Yeah, sorry, I had a small question regarding this feature. So basically, in this feature, like we are now adding capability to Kyverno to match with custom resources as well, right? Like if I'm not wrong.
So Kyverno could previously also handle custom resources, but one of the problems we would run into is like in this example Venkatesh showed, some custom resources have the same name as Kubernetes native resources or I guess internal
Conflicting
resources.
names, you mean?
Right. So that's why you need to specify the API version or the API group to to match what you want.
Okay, okay, okay. So
Yeah, I think this
basically,
was
like,
one example, and then Chip, I think there was a CNI that you were using, which had also a similar conflict, right?
Yeah, network policy. So it's the idea of this feature is to more accurately steer Kyverno to the exact type of resource you want it to validate and not have it guess.
all right, all right, all right. Oh, okay, okay. So actually, while looking at this feature, I like a theoretical edge case struck my mind. So I was thinking, let's say there is some user who mischievously, creates a policy which actually denies deleting cluster policy itself. So let's say I create it, and in the future, let's say I want to delete that cluster policy, but I won't be able to delete it because already there is a policy which denies the deletion of cluster policies. So is a case like that like held like dealt with in the code, or like because it's going to be a deadlocky state?
Yeah, not in, so we don't have any specific checks in the code. There are some, when you install Kyverno, it excludes certain resources. So there it is configurable to exclude policies and cluster policies. I think that's the default.
All right.
Also, of course, you would want to use RBAC to control who can manage policies, right? So you can't have, whether it's inadvertent or malicious, you don't want, others to add cluster policies if they don't have the right privileges.
Sure, sure, sure. Cool, got it. Thanks.
Right. And you can also use the exclude block and the cluster policy to let some of the users able to delete that cluster policy if you're doing it with Kyverno.
All right. Cool. Thanks.
Okay, great. Any other questions for this feature? All right, so next we'll have Arsh talking about the set operations for the operator in and not in.
Hi folks, sorry for joining in a bit late. I thought the meeting was at 10:30 like last time. I'll share my screen. Yeah, so earlier, like when using in and not in, you could match only a single thing, like if a particular thing, like sets were not allowed basically, and now with the recent PRs, we support subset checking. So example for that is like if you have a service where you have defined some external IPs which are like not singular, uh, then like you might want to deny a particular set of IPs. So what this will do is that will check if those IPs are in these values which you specify, and if that's the case, then this policy should deny them. And we'll see that in action. kubectl. So yeah, in this example, these policies were present. So like this was in that set, so it got denied. But let's say if we have something which is like not there, then this would get created. Yeah. So this was the main idea, and I think I've not followed up, but today there was some changes in the working of Norton shooting. Do you want to clarify, like get the
Yeah, so
idea from
here for that one, the use case is that like for not in, if user defined that S1 is not in S2, that means no value of S1 is present in S2. So previously we said each and every single element in S1 should not be in the list S2. But in this case, if there is a single element in S1 is not in there in S2, then we're gonna deny, in this case, denying the request.
Yes, I think the initial implementation was doing more strict set operations, but I think in real world use cases, what we found is doing a individual element comparison. So from if you treat it as two lists and you're comparing if the each element of the first list is whether it's in or not in, the second list is more practical, right? So we've kind of switched to that behavior. So anyways, and I think there was also a suggestion to have maybe more explicit, things like all in or any in and things like that. So we could extend the operators if needed. So if anyone has use cases, feel free to, comment on that, and it should be possible to extend the set of operators there.
All right. Thanks for the team, Pooja, Venkatesh, and Arsh. That's the demo we have. And next, I'm gonna talk about the current work in Kyverno. So there we first have this Prometheus integration. So we recently submitted this project as a Linux Foundation mentorship project. So there we have excellent contributor Yash is working on this Prometheus integration. Yash, do you want to introduce yourself and talk about this project a bit?
Yeah, sure. So hi everyone, I'm Yash, and yeah, currently I'm working in a company called Grofers in India. And yes, I am the lucky one who got selected for the LFX mentorship under Kyverno. So as a part of this mentorship, actually this was the project, which was the Kyverno Prometheus integration. And just to lay it out in layman terms, basically this project involves exposing a slash metrics endpoint at which Kyverno will expose a good bunch of a really relevant bunch of metrics like associated with the violations, like at the granular level of rules, at the high level of policies, even at the high level of admission reviews as well. So that was the idea basically to increase the capability of observability over Kyverno. So that itself was the motivation, because Kyverno is basically a policy management engine, and yeah, like it actually poses a good set of opportunities to provide a good set of insights to any cluster administrator as to how the policies are conforming to the cluster. Are the developers facing a hard time creating resources? What if they are facing a lot of violations? So basically metrics, giving these sort of insights to the cluster administrator. That's the kind of motivation behind this project. So I guess we can move on to the goals. So speaking of the goals, the idea is pretty straightforward. That like as we can see that Kyverno is a pretty simple and convenient to deal with policy management engine. So that sort of idea also we want to maintain with this Prometheus integration. We want to expose metrics in a not a naive manner, but rather in a mature manner in such a way that for the end user they end up getting the maximum amount of insights by dealing with minimal amount of metrics rather than dealing with a crazy bunch of metrics. And the metric should be capable of providing high level insights like a 10,000 feet overview of how policies are performing over the cluster, as well as the capability to monitor or track the cluster at a rule level for the policies. And yeah, the basic idea is to ensure that these metrics end up proving as a good set of SLIs, service level indicators, which can actually help in setting up a good set of SLOs, error budgets, service level agreements, etc. So these are basically the goals or the targets of this project. So speaking of its working, so from the like from the perspective of the user, basically Kyverno will now start just exposing a service at which the slash metrics endpoint will be exposed. And assuming that a user has a Prometheus server setup, they can just edit the scrape configs to now start polling Kyverno at the service endpoint, at the metrics endpoint, and scrape the metrics. Behind the scenes, from the Kyverno side, Kyverno will be actually running this entire code of Prometheus. Is going to be running a Prometheus handler, which is going to look for all the relevant events happening across the cluster associated with policies, and all according to the like as a response to the set of right kind of events happening, it's going to create metrics, update metrics, and yeah, store the metrics. And if the user has a Prometheus operator installed on the cluster, then well, they can be capable of using a service monitor as well. But yeah, basically Kyverno's job is to basically just generate the metrics. Rest assured, it's again in the hands of the user to do whatever they want with these metrics. They can play around with these metrics in their Prometheus console. They can use these metrics to create really insightful dashboards over Grafana. That's their choice. All Kyverno is doing is basically generating and exposing a really relevant set of metrics. So yeah, moving on, we have actually planned a bunch of metrics for Kyverno. So basically, speaking of the first one, just to give a short summary, it's basically a Kyverno policy rule results. And as the metric name suggests, basically this metric will consist the data, the results associated at the rule level for any policy. So let's say a user created a pod, and when the user created a pod, let's say it went through let's say 5 policies were constructed in such a way that they ended up evaluating that request. So over those policies, how many policies executed successfully, how many policies executed unsuccessfully, which of them executed as a part of admission request. In this situation, it would be an admission request. But what if it was a background scan? All of these kinds of data associated with the result of this execution, it's going to be stored in this metric. And the value of this metric is going to be 1. It's a boilerplate value. It can be a counter or a gauge that doesn't matter. But the point is then, like, there are multiple use cases which the this metric can cover. For example, if the cluster administrator wants to see that in the last 1 hour, how many policy successes or how many policy violations happened. Let's say the cluster administrator wants to see that over the last 1 month, like, were there a lot of violations happening across the cluster or not, and if they were happening, then the cluster administrator could tweak their policies accordingly. So that's basically the gist. And I guess Shooting has shared the this document over the channel as well, so you can check out this document in depth. We have specified all the labels, all the allowed values, and the descriptions as well. So moving on to the next metric, yeah, basically like all the kind of values, are possible. Yeah, moving on to this next metric. So this one, as the name suggests, given no policy rule count. So this basically ends up tracking the the number of policies existing in the cluster, and including the rules as well. So you can also at any point in a cluster, let's say you want to see that okay, right now how many active policies or how many active rules are operating in my cluster. You can actually track the count of it. And let's say you want to filter it on the basis of let's say how many policies with background mode enabled, or how many policies of the type enforce, or how many policies of the type audit, or how many validate rules, how many mutate rules. All these kind of stuff can be tracked with this policy from this metric. So basically, a cluster administrator, it will give the cluster administrator a good set of visibility around like, are they over exceeding the number of policies they are dealing with or not, right? So that's the thing. So yeah, it's a pretty short metric. It's not and yeah, like there is one theoretical edge case to that. So like there might be some situations where let's say I created a policy but now I deleted it. Now behind the scenes, Kyverno can't delete the metric as such, but that's why we are using the value of this metric is going to be a gauge value. So if the value of a metric is 1, that means that policy exists. And if the value of that metric, given the policy rule count, is 0, that means that metric was sometime created, but now it's deleted. So that's basically the quick idea. Moving on to the next metric, which you are seeing in front of the screen. So it's the Kyverno policy changes, and at the name suggests, it basically tracks all the changes of like all the history associated with all the policy level changes associated with all the policies. So let's say I created a policy, this metric is going to track that. Let's say I updated this policy, I deleted this policy, all of these kind of metrics or this kind of history is going to track it. So let's say I want to see as a cluster administrator, I want to see that okay, if someone is tampering a lot with my policies or not, I can just simply query this metric and see that how many updations happened in the last 24 hours. Let's say 15 policy updations happened in the last 24 hours. Then that might sound something fishy, that the policy should not be updated that often. And similarly, deletions and creations of policies can be tracked as well. And again, this metric can be filtered on the basis of the policy validation mode, whether it's enforce mode or audit mode, or is it a background enabled policy or not, etc. So moving on, I guess only a few metrics are left. So yeah, so given the policy rule execution latency, again as the name suggests, it's going to basically track the latency happening, latency associated with executing rules, like at their individual level rules around Kyverno. So whenever you let's say create a resource and it ends up hitting, let's say a rule which evaluates whether this admission request should be succeeded or not. Well, this metric is going to calculate the latency associated with that tool. So there might be some situations, there might be some, let's say some issue happened with Kyverno. The cluster administrator created some rule or some policy in a messy way, which is causing the rules to execute, like taking a massive amount of time. And this is actually, slowing down the performance of the cluster. So this metric can actually help, the cluster administrator to track down that specific policy or the specific rule, which is, spiking the latency of the cluster. And of course, we can just sum over the rules to track policy level latency as well. Because again, a policy's latency is basically the sum of its individual rules latency. So again, it's also representing the latency in milliseconds, and the value is going to be presented by a gauge vector. And yeah, it provides granularity at the level of policy, resource, rule, etc. Moving on. Yeah, Kyverno admission review latency. So this is an interesting one. So basically, there might be some situation. Let's say you created a pod again, and let's say it ended up triggering 5 policies, right? Now you want to actually track the end-to-end latency of evaluating that pod request. That, like, how much time did it take for Kyverno to evaluate whether that pod is, ready to be created or not. Now behind the scenes, it's going to involve the end-to-end latency of, how much time did all the, the policies or all the rules took to evaluate that thing. So it's a pretty high level latency, but yeah, it's a useful metric to just show, general idea, a general overview of how Kyverno is operating. Or let's say there might be some situations, where Kyverno might be slowing down whenever a pod is created. So the cluster administrator can say, okay, fine, let me see all the policies associated with, evaluating the pod and find the loophole where things are getting a lot latent. So this metric basically tracks, how, like, as a part of any admission request, how many cluster policies or how many policies or how many mutate or validate rules are actually trying to evaluate the incoming request, and corresponding to that request, how much end-to-end latency is being consumed. So that's the basic idea of this metric. And
that would be a really good metric to track for internal development purposes in your pipeline. So when you're running tests on new builds, this is a KPI for how optimized your code is. So if you're pushing new code and you're looking at this metric and you're seeing a 10-fold increase on that value, well, something might have been done that needs to be rolled back, because that's going to scale. You're going to have linear scale problems when users roll this out and they have hundreds of things to apply, and now that's going to take down a bunch of other resources. So this is a really key one to have for users, but also for development purposes, I see.
Absolutely. Yep, agreed. Yeah, as Chip said, yeah, we can, like, it can act as a really nice set of KPI, and yeah, we can define SLO on the basis of that. So that's a good metric. Moving on, we have 2 more metrics which are basically conveying the CPU usage and memory usage associated with Kyverno. So Kyverno, just small heads up, Kyverno, when you install Kyverno, behind the scenes there is one pod of Kyverno which is running. So there might be some situations where you want to track how much CPU usage or memory usage this Kyverno pod is like utilizing. Although regarding these 2 metrics, we are kind of skeptical around to finalize whether to finally include this metric or not, these 2 metrics or not, because again, technically we have already other offerings like cube state metrics and other tools with which you can track pod level CPU and memory usage. So like creating this metric will be kind of like reinventing the wheel, but yeah, the benefit of keeping these metrics as well is that, like, these metrics will be under the umbrella of Kyverno metrics. So there are some pros and some cons associated with keeping these 2 metrics. So this is kind of in a vague state to include this metric or not. But yeah, regarding all the other metrics, is pretty final. And of course, we'd love to hear any suggestions, any additional metrics you folks want, or just any sort of suggestions. And I guess this document also shooting as uploaded on the Slack channel. So please feel free to comment on any metric, any doubt associated with any metric. Yep. Any questions regarding anything? Shoot.
So I have a question, and by the way, I'm very excited to see this. We use Kyverno primarily for namespace or automation around namespaces. Teams typically have a namespace requested, and then Kyverno goes and puts in a whole lot of things around that, role bindings, quotas, all of that. We have quite a bit of churn in our clusters, so sometimes we see, it's a minute before a generate request gets processed. That causes issues downstream where, teams are expecting to have roles in place and they aren't quite there. So you've got a metric there for rule execution. My understanding is generate requests are executed asynchronously in a different queue. Would that cover the execution time of generate requests, or do we need a separate way to measure those?
No, this same metric will evaluate and track the latency associated with all the kind of metrics, be it validate, all the kind of rules, be it validate, mutate, or generate. So
Okay.
yeah, like with this, you can actually track the end-to-end latency of this thing.
Oh, okay, I see you do have generate there. Okay, that's interesting.
And obviously, like if this policy, is like if a certain policy is running as a part of background scan, then obviously in all the situations the rule type is going to be validate, because again that's how Kyverno works, right? As a part of background scans, it only runs validate policies and not the mutate or generate policies. But yeah, that's how it's going to work. It's going to cover your generate related rules.
Right.
Okay.
We've discussed about the generate rule latency, as Kyverno internally creates a middle object, generate request, to process a generate rule. So in that case, we have a field in the generate request to see if this policy or this rule gets successfully executed. So from there, we should have some of the latency for the generate policies.
Yep.
Okay.
So, but would
right.
we need a separate metric then to track the time taken to handle the generate request itself versus the time taken to do the admission control portion?
No, this metric itself is tracking the the entire any kind of rule basically happening as a part of admission request or background scan. Any kind of rule which is maybe a generate or a validate or a mutate rule, this metric is covering under its own umbrella. So I try to evaluate this actually, like, do we need a separate tool for it's admission or background scans, or generate and mutate tools? But like there was a lot of overlap and redundancy, and I'm very sure that this metric is going to be reliably cover all the kind of edge cases for that matter.
I may have missed it. Is there a metric? Are you proposing a metric to provide the count of objects that get sent to Kyverno, that the total number of objects that it sees, not the results of a rule, but let's say that you're in a cluster and there are 100 objects that are sent through admission review that Kyverno catches, that it looks at, regardless of the number of objects that it declines or fails to validate. Is there a metric that you're planning that shows what that total of number that are being streamed into Kyverno are?
Yes,
because that would be very helpful.
Latency, admission review latency is, I guess, conveying that kind of metric. But the only issue with that is that it's like showing you that per admission review, be it generate or anything whatever, but like how many generate tools, how many resources are being applied, and how many rules are being executed as a response to that. But again, that's the part of the labels and not the metric value per se. So that's going to be slightly issue for the end user. So yes, that's a good suggestion. Actually, we can take this into the suggestions and add this metric as well.
Yeah, because the reason I'm asking is because a common request that I've seen and that we're going to get is, I want to know how effective this tool is in my environment. And the way that you'd answer that is to compare the number of incoming requests versus the number of requests that were blocked, for example, if you're just talking about validation. So you need to be able to show a ratio. And the only way that you do that is to have a raw number of everything that came into a Kyverno, and then a number of all the things that it blocked, and then derive a percentage from that. So because that's, customers, users are going to ask, is this blocking, like, how successful is this tool being? Is it blocking 5% of my requests? Is it blocking 50%? Because I have a bunch of users that aren't doing what they should do. So that's the user story behind having a metric that shows total number of objects that Kyverno sees, quote unquote sees, and total number of things that it blocks.
Okay. This is a really good point actually, because the results are being tracked by this first metric, which is in the front of the screen. But that's a good point, showing the ratio between incoming versus the requests which actually get blocked. Yeah, actually, this is a good point. We can take this
So
solution into account. Yeah.
Either if that's, and I'm not suggesting that, may not be suggesting that there should be a metric provided for that ratio, but at the very least provide the raw data of the incoming object so that users can build a query to get that ratio themselves if they want to. Many of them may not, they may not want it, but at least the raw data will be there so that they can build that into a dashboard if they want.
Fair enough. Agreed. Yeah. Yeah, I guess you can take this into suggestion and build a metric out of this. Sure.
I have a question for that. Do we want to take account for all of the admission requests that are forwarded to Kyverno, or only the resources that are matched by the policies, by Kyverno policies?
Yeah, good point. I forgot to mention that. I would suggest only the ones to which there's a match in a policy.
Okay.
Because
Okay.
the policy is the scope of the object coming in, not everything in the kitchen sink.
I guess if you are talking about a situation where we are basically tracking all the requests which are hitting some rule or some policy, I guess that's going to be tracked by this Kyverno policy rule results itself, right? So let's say I want to calculate a ratio between like basically how many incoming requests are hitting a certain rule versus how many were the total hits to the Kyverno policy. So I can just create a metric out of this. Basically create a metric saying that, okay, I just want the results associated with this rule divided by the total results. So that's gonna give me a decent ratio in my opinion, like the right kind of ratio between how many incoming requests are actually hitting a certain rule, to see that if that rule is being applicable, if that rule is blocking a good amount of requests or not. But I guess I can build actually to more exemplify it in a better manner. I guess as a part of this document as well, I can explain this thing, in a more descriptive manner using a sample query or something. And
I mean, it may be a second metric. It may be, to Shuting's point, it may be that there are two metrics. There's one that shows the number of objects that Kyverno operates on, which is a function or is being filtered by policies that are applied, but also another one that just shows total number of raw inputs being handed to Kyverno, regardless of what policies, even if there are no policies, and if it's sending the API server sending 200 a second, that could be a metric that people are interested in.
I'd agree with that, the latter. To be able to understand how efficient or how well you've described your policies to reduce the load on Kyverno, just looking at the Kyverno filter, we've gone and excluded secrets and config maps because we don't need policy around them. But to be able to see that that's actually had an impact on the number of evaluations that Kyverno is doing with every rule, that would be useful.
Yeah, because then you could correlate that number to things like memory and CPU usage to see what total effect that's having on the software.
Exactly. Yeah.
That's a good point, actually. Yeah. Let's take this into account and let's have a metric dedicated to that.
Okay. Yeah, one thing which would be good to address somewhere in the document, if we haven't already, is how this tool fits in or complements like the other tool that Frank from the community also has built around the policy report dashboards, right? Because I mean they're two different things, right? But of course, anyone using Kyverno will want to know how both tools, what they provide and how they work together. And I think we should, see if there's any, again, room for like how between the two implementations, if you're building other Grafana or other dashboards, if there's ways to collaborate and, even get some things together for an admin.
Sure.
It would kind of be cool to see both of these offered as an optional sidecar, so that users could just point a browser, optionally if they wanted to, at this and be able to, see this without having to require any external infrastructure, but also get the visibility of the Prometheus metrics. So there could be a lot of value in that as a way to bundle both of these together in a sidecar that could be deployed with Kyverno, or even if not a sidecar, then an ease of deployment and packaging, so
Right.
that users could quickly get some visibility.
Okay. So just to confirm, you are suggesting that, like, let's say as a user, I don't have my Prometheus setup, so there should be a capability or an option to me, so that Kyverno itself, as a part of its installation, can have its own Prometheus sidecar, which is handling and storing the metrics. Are you suggesting that?
Well, this right here, Frank's project basically does that. It provides a a sandboxed way to get some of that data without requiring Prometheus and scraping and all of that other stuff. I'm just saying that your two projects might collaborate together to
Yes.
expose your metrics in a simplistic way like this without having to defer to Prometheus. I mean, in production environment, you probably would, but this might be something to just quickly say, hey, what does my environment look like, rather than having to either go to another team, having to export them across to another separate piece of infrastructure, all that type of stuff. Just an idea.
Sure, fair enough. Yeah, actually went to this like policy exporter for the metrics only, but I didn't know that he was actually, this project actually dealt with that sidecar-ish part as well. That's actually pretty cool. I'll check that out. And yeah, we can of course collaborate with this project as well. Sure. Yep.
Yeah, one other quick question is, I know today we have in the policy status, there's some metrics, I'm not sure if those are being used or if the plan is to deprecate those. And of course, the question there is like, will we be putting these new metrics also in the policy status, or will they only be available from the endpoint? Because I think we've run into some issues where if you're updating policies too often, that itself generates more traffic and things like that.
Sorry, I didn't get this question.
So
Right.
today, the policy status contains some of the basic execution metrics that we have, and those are updated I believe every minute or every fixed interval based on things that are buffered in memory. So I don't know if we're still planning on keeping that or removing that, or if there's been any discussion yet on what to do with the policy status.
I can quickly share and talk about this. So this is one of the policy YAML, and the like in the status block, we have some rule execution time here. But the problem we see with the policy status is that whenever we have a flood of admission requests, we're going to update the status more frequently. So that will cause like the client side throttle on the cluster policy or the policy object itself. So the plan was to deprecate the status in the policy field, and instead we'll have something in the Prometheus exporter.
I'd say that makes more sense,
Right.
because you're separating concerns now.
Right.
Yeah, and this seems non-scalable, right? So I agree. I think we should just remove this.
But make sure that all of the same information needs to be exposed in a metric if you're gonna deprecate and remove it. So
Yeah.
Right. Any other questions around Prometheus?
that's gonna be a great project. So best wishes and congrats on that. That'll be a great thing for everybody who uses Kyverno.
Yeah. All right, let me move on to the next issue. We have the image variables feature is currently working in progress. And I believe Arsh is working on this one. So the use case I see for this one is to replace the image registries or the tag based on like a certain match. So in this case, with these built-in variables, you should be able to extract image registries, image name, and also the tags. for your containers and then replace it to a different registries you want to use. So we're pretty close on this, and hopefully we can get it down in the next few days. And also move to the next, we see some of the use cases for the anchors in the mutate policy. Let me quickly pull up the issues. So for the equality and existence anchor, we are not currently supported in the validate policy, but there are some use cases like if I want to mutate my resource, if a certain tag is specified in the resource, then in this case, if the empty-dir is specified, I want to insert the medium type tag as memory in my policy, in my resource. So this is the use case of the equality anchor, and we already have a PR for it. It's working in progress. And another one is the existence anchor. So currently today, the issue in Kyverno is that for the strategic merge patch, it really depends on the patch strategy defined by Kubernetes to for the default patch behavior. For example, in this case, the tag for the patch strategy for this tag in from is replaced. So by default, if you specify any policies, any mutate policies on this tag, it'll replace the entire object other than append to the list. So to have something like append to the list, I'm proposing to have this existence anchor in the policy. It means that here is the example. Whenever we see this existence anchor on a certain tag, we're gonna say that each element in this list should at least must be present in the resource. So for a mutate rule, if this tag is not there, we're gonna add the entire object to the resource. But if it's already there with some other elements in the list, we're gonna append it or insert it to the list. So in this case, we can kind of work around of the default patch strategy and then let the user to insert it to the list. So that's the two use cases for the anchors.
Yeah, so one of the related proposal that I was briefly discussing with Shooting is to even change the name to better represent the behavior now, because to call this patch strategic merge generator, because really what it's doing is it's internally generating a series or a set of patches based on the patterns we're describing here. So either based on the list behaviors or for the conditional anchor or this existence anchor, it will generate the right set of patches accordingly. So yeah, it's subtle, but I think it's fairly powerful, and we'll have to, of course, test and document this and make sure it's easy to understand and use. But yeah, pretty nice change here.
Yeah. And move to the next HA support. We're currently, what we have in the design doc, will support the HA mode component by component. So currently the webhook registration controller is almost done. So with the latest main branch, one should be able to scale up Kyverno to multiple instances. But still, I have a few things left to migrate this webhook registration controller to use controller runtime, where it can enable leader election. So in that case, we can say that the webhook registration controller is fully HA. And it also fixes that the issue that previously we cannot accept custom self-signed certificate during the Kyverno start. So right now it is fixed in the main branch. So after this, one should be able to start Kyverno with their own generated self-signed certificate. So the plan is to release it by in 1.35, which is target to be released by this week. So at least I'll have the release candidate. I'll push out the release candidate for the users to like test a bit more, and then we'll have 135.
Will the inactive or the passive pod do any work there? Would that help with performance, spreading load at all, or not?
No, not for the webhook registration, because there is not much work for this controller. So it only has the leader that is actually working on. But for the controller, like background controller or the generate controller, there we might want to distribute the workloads to different workers. So it might have different mechanism internally.
Okay.
Yeah, one other, I think it's there's a pending issue also for the generate controllers. I think there was some discussion of increasing the number of workers internally. So today it's just running as a single worker task, but we want to make that configurable and also increase the default to at least 3 workers to do more, generate operations concurrently. So that may help speed things up a little bit as well.
Yep, that'd be great. I know Chip blogged an issue a little while back about making generate requests synchronous so that the webhook only sends a successful response once it's generated. But obviously you want to know that you can get through the generates in a X amount of time. So being able to now measure the generate length and having multiple generates, maybe that becomes more viable.
Right. Okay. Yeah, and the last item here I just added was, with James Path, we're adding several custom functions, mostly for string manipulation and regex operations. And initially, these will just be used in things like preconditions or wherever you're using James Path, and the results would be something you want to store as a separate variable. So that solves some interesting use cases, and I think some of that will also be available in this 135 release.
Okay.
Cool.
I just want to quickly mention that we have another Linux Foundation mentorship project, which is to integrate litmus chaos testing with Kyverno. So we're still at the early stage of that, but just wanted to brought that up to the community. So in there, we're gonna introduce some of the chaos testing. So for example, like what we mentioned in the Prometheus integration, whenever we have the flood of admission requests, we want to measure how Kyverno performs, and what if the Kyverno pod is going down, what does that mean to the cluster, etc. So I think it's going to be exciting.
I think Mahfuza is also online, right? She's the one.
Hello, Jim.
Yeah, pretty excited about this, and I think it would be interesting to also see if Kyverno can play a role in other chaos testing.
Yeah.
Cool.
All right. I guess that's all for today's meeting. Thank you, everybody, for joining. I'll see you in the next community meeting.
All right.
Bye, everyone.
Thanks.